As of this morning, about 100 students seem to be enrolled to this course, but we are not 100 people here. But you will see that when I explain how I will evaluate your success and how you will pass, etc. You will notice that you need to attend the courses. I will explain. So, even for this week, those who didn't attend will start missing the attendance sheets, even starting from today. So today we will make a quick start to some of the basic concepts. Tomorrow we will continue. Every week we need attendance. So what is this that we need attendance for? It is the EEM 205 Signals and Systems. And it's a mandatory course for electrical engineering curriculum, and you need to pass this before graduating from this university. And I am Ömer. Probably you already know me, and you know where my office is, you know what my phone, internal phone numbers, etc. You all know those things, I suppose. We do have a communication medium in terms of the announcements, probable projects or homeworks, if there will be any. And as you see, the assistant is recording the course. The records will be available as well in some public mediums such as Dailymotion or YouTube, whatever. And prior to that, the communication medium is the Facebook. Some of you guys have already started liking the page that I have published. And all of the students, in fact, need to do that. Because once you like it, you will be able to follow whatever we have, announcements we make. And all the updates will be from there. I particularly enjoy using that page for the updates because you guys have smartphones, most of you, interestingly, and you get updated immediately. For example, last year, a student asked whether, by email, the student asked whether calculators will be allowed in the examination or not at 11 o'clock at night. Okay. And at 11:30 I saw it, and I answered it by publishing on the web page or the Facebook page. And half an hour later, I saw something like 85 distinct users saw the message. So you immediately know that, for example, calculators are not allowed in the examinations, for example. So it's a very fast communication medium. That's why I prefer that. There's a lot of names going on inside the web page. There was, and I still don't remember the exact HTML address of this Facebook page, but you may go to the department web page for courses. There we do have a page as well, and from there, when you click, you will be jumping to the Facebook page. So if you're having difficulty, please ask one another. Some of you guys have already discovered the web page. Please go there and please have a Facebook account, and please make a like to that page, and you will follow everything. Okay, that's one of the points. So communication is by Facebook now. Now, a critical question. We have several critical questions. I'll try to answer each of those very briefly. Like, what are the percentages of the examinations? How will you get the grades? And what sort of grades will you expect? What do you need to do to pass this? How will you finish this course, etc.? What are the percentages as a start? But before that, the more critical question that you may ask, and as a matter of fact, you should ask. And if you don't ask that question, it means there's a problem about your involvement in the electrical engineering. The question is, why am I taking this particular course? Why on earth is there a course named Signals and Systems in the electrical engineering? The same question is valid for all the courses that you take. Most of the courses. You may expect some motivations for courses like circuits or electronics, because, well, it's an electrical and electronics engineering anyway. But why do we have the other courses? This is, the concept of signals and systems is so fundamental that, in fact, not only the electrical engineers, but also other engineers should be taking it as well. And it's a critical course in that aspect. What is that? And why? Because it's the answer to this fundamental question of an engineer. What does an engineer do? What are you supposed to do? Why did you choose the electrical engineering or any engineering in the university entrance examinations? What brought you here? It may be just chance. Okay? I didn't choose it, but my grades were available for it, so I'm here, you may say. But nevertheless, you have finished already at least 2 years, and you are here. So you should be aware of all these concepts that an engineer must do. An engineer is supposed to take this kind of shape, a diagram, an input arrow, a box, and an output arrow. As you may guess, this input arrow is the input that we have to this so-called system. We will name it as a system, but for control theory, for example, it may be a plant, or it may be anything. In mathematics, or in this course, we will call it the system. And the inputs to those things, they may be currents or voltages. It may be other data that may feed the plant, so that it works somehow, according to a rule, of course, a mathematical rule. And it generates another so-called signal, the output arrow. So the arrows are signals, input and output signals. And this thing is the same for every engineer. It doesn't change. For electrical engineers, classically electrical engineers, this box, inside this box, what we have are circuits, maybe, right? We have capacitors, inductors, resistors, transistors, diodes, even integrated circuits. Well, so the input is a voltage, maybe the output is another voltage then. In some cases, there is no input. It just works by itself using some DC. And that DC is an input now. So it just runs by itself and produces an output. This may or may not exist, but usually the output signal exists because that is the observation of your system. You have to make a measurement from your system. And that measurement branch will be then your output arrow that we have here. So that's how electrical engineers may work, for example, but mechanical engineers will also work the same way. Then, inside this box, we may have machinery, oscillators, dampers, friction surfaces, moving bodies, etc., some mechanical system. And this is the observation that you measure, which may be the displacement of a pendulum, for example, at some point. The position of something. So it's also necessary for mechanical engineers. This thing may also be, what else? A chemical process. So chemical engineers will also need it. The difference between an electrical engineer and a chemical engineer is that we are able to solve this problem using circuit elements, and they are able to solve the similar problems using chemical processes. We pour this amount of this substance and that amount of that substance and heat, etc. All those things, heats and such, are the inputs, and the output is the purity of a substance, for example, how pure something you get, for example. So that is chemical engineering. A more recent discipline about engineering is computer engineering, and for those, what you have to do is you have to write a program, and it's an algorithm that runs inside this box. The inputs are entered from the keyboard or the mouse, or the screen, whatever, or speech, and the output is the way that the program works and generates the output. It's usually on the screen then. So an algorithm is also this box, and computer engineers are also doing the same thing. Industrial engineers are also doing similar things. They are optimizing something, and the optimality criteria is the output observation. So this is engineering then. And as engineers, you're supposed to do it. You're learning circuits, electronics, etc., all those things, because you're supposed to solve this problem using circuitry, electronics equipments. But being able to solve it mathematically is more meaningful than that, because the circuit elements that you are using now will not be available tomorrow. Okay? Perhaps the capacitor will be something different. There will be different integrated circuits, there will be different semiconductors, not semiconductors perhaps, different elements that you will design your circuitry. So being specific to a circuit theory is not enough for an engineer, because you're expected to work years ahead. So instead of circuitry, what you really need to do is the mathematics behind the system. Because the only thing that doesn't change is the mathematics about this input-output relation. It didn't change, and it's not going to change. It doesn't change as fast as technology. The technology that you use inside it, it may change. A good engineer and a bad engineer thereof shows the difference in terms of being able to adapt to those changes. And as a matter of fact, that's why we are teaching this course in English, not in Turkish. I'm sure if I explain everything in Turkish, you will better understand what each element is essentially doing. You will understand it very well. But I'm telling you that it's not important. Being able to adapt to the systematic that you're expected to learn is more important than that. Obviously, there is a problem about starting power, starting units. We'll talk about that later. So that's why we are having this course, Signals and Systems. It's a mandatory course in all engineering disciplines, as I say, but fortunately enough, it is still a mandatory course for electrical engineering, and it's not a mandatory course for other engineering departments, and I am sorry for them. They need to know this thing as well. If they don't know these things, I wouldn't call them proper engineers to be able to adapt any kind of a technology using the mathematics, the fundamental mathematics that we see. So then it concludes us that this is a math course and nothing else. It's not a technology course. But we will see a lot of technological things in the course as well. And we have to give examples, we have to do projects for real life in engineering using the current technology. We will do that. But so this is the course. And how are we going to do this course? 2 hours today and 1 hour tomorrow. Attendance is mandatory, and the attendance will be checked in a different way as we started last year. Okay. What did we do then? And we are going to do it again. We will have quizzes. Okay. We will have one quiz, usually in the beginning of the Monday hours. And we will have another quiz at the end of the Tuesday hour. So at the end of the week, we will have another quiz. That's 1 + 1. This first quiz, and the questions are quite spontaneous. I'm not going to design those questions or whatever. I'll just think of the question and I'm going to write them. These two quizzes will not be evaluated according to your grades, okay? They will not be reflected to your grades. So whether you give a correct answer or a wrong answer, it doesn't matter. They won't be evaluated at your grades. But this first quiz will be your attendance for the 2 hours today. And the second quiz tomorrow will be the attendance for tomorrow's hour. So don't come and tell me that, well, I couldn't solve the question, so I didn't submit the quiz. Don't say it. You have to submit. I don't care whether it's correct or incorrect. That will be your attendance. If you don't submit, then it means you didn't attend the class. And you may fall into a different problem. The first quiz will be in the beginning of the week, somewhere around there. And that is usually something like related to the things that we will see throughout the week. For 3 hours we will see about these things. But we haven't seen them yet. So why am I asking it? I'm asking it so that I will see whether or not you already know it. Probably you don't know it and you have no idea. So you may just try to improvise, give some ideas. I don't know it, but since I'm an engineer, I may do it like this or like that. Try to give some answers. Those trials will be in the first quiz. The second quiz will be at the end of the 3rd hour every week, and it will be regarding the material that we have seen. And I'm expecting you to solve it then. You should be able to solve the second quiz. This one. This one you will probably fail, and this one you will probably pass. But of course it doesn't matter, you may even fail this one, I don't care. I mean, you won't be evaluated according to those things. This is for me to observe how things are going. If you also fail here, then I will, for example, say that, well, in that week there's a problem, and the people didn't understand what I'm talking about. That's what I will understand then. So these quizzes will be your attendance. And for that, you will need to carry some piece of paper. Because I'm not going to submit any questions or anything. Just tear off some piece of paper, write the question, write your names, give your answer, and sign it. That's your attendance, essentially. That signature is more important than the answer. So that is the attendance. What else do we have then? We have, of course, midterms, homeworks, and everything. There will be 2 midterms. A project and a final. So as you see, there's no quizzes or anything. The first midterm will be considered as 20%. The second midterm and the project, I want to make them 25% each. And the final is 30%. Okay, that will be the combination that I'm thinking. Unfortunately, the system, the system that we use in this university doesn't allow me to put any final with a percentage lower than 40%. Okay, I'm not able to do that. So I'm going to give it a 2-piece final, and it will be 40%. The 2-piece, the first part will be 25% and 75%. This 75% of this 40% will come from your final examination, in-class final examination. So it will be the second part of your final, which is your final. What about this first part of your final then? That first part of your final will come from your second midterm and project. I will add some content from the second midterm and some of your grades from the project. I'll combine them and make it as the first part of your final with a 25%, which will make these two 20% things to be 25% each, and it will essentially make your eventual final to be 30%. Okay, it's a little bit complicated perhaps, but what you really need to know is this. Your evaluation will be finally, eventually, this. Alright? Don't care about what the second midterm says in the system or whatever. Okay. And this is the assessment, the evaluation. What else can we talk about? Yeah, the videos that we have. The videos will be available in public shared medium that will be announced in the Facebook page, as I said. But, of course, we cannot guarantee the accuracy of the uploading process. Because in many ways, the videos are relatively large and it takes a lot of time to process, to post-process the videos and to try to upload them. So don't rely on them, okay? When you miss the class, it may not be available until the examination, for example. I cannot guarantee that. I'll try to make them available as quickly as possible following the courses, but we can never guarantee that. So you can think of those things just as some auxiliary or supplementary material. You don't rely on them, but I'll try to make them available. And the videos of the last year are available already. So you may take a look at those things as well. It's the same course. You will even notice that I'm following very similar things in the first hour of the previous year. Okay? So that's a nice thing. And what else? We have a textbook. It's a classical book, Signals and Systems, by Oppenheim and we'll see with Nawab. It's the second edition that I have here. As I said, it's a classical book. It's not the best textbook to teach signals and systems. But it's popular, and the notation that we will try to follow will be from this textbook. As the time progresses, you will see that most of the notations regarding the time variable, the frequency variable, some symbols for the operations, etc., may vary, may be different among different books. I'll try to stick to this notation, the notation by this book. And trying to follow the course from this textbook means at least, that's a minimum requirement, at least to try to solve all the questions at the end of every chapter. The questions, we have many questions at the end of the chapter, but they are not enough. They are just merely beginning to warm you up, perhaps. They won't be enough. At the end of the first midterm, you will understand that they are not enough. But they are necessary. If you don't solve the questions, if you come to an examination without solving all the questions from this textbook, you will have no right to claim anything regarding the examination. Don't complain anything. You have to solve all the questions. So the textbook is already mentioned. And as I said, the questions will not be enough. You have to solve several extra questions. There are very nice, but not so classical as this one. Textbooks like the book by McLellan, for example, or Schaum's outline of signals and systems. Such outline textbooks are particularly good for exercising. This textbook is good for reviewing and trying to understand again, if you don't understand something, because it is verbal, it explains. The other books that I'm mentioning, they have more exercise questions, which may be even more useful for you, because you have to exercise a lot before coming to an examination. And without exercising, what you learn will not be learned. It will be taught. I will teach you. But learning and teaching are two different aspects. The learning concept, teaching by me, is only a part of it. A majority is by exercising by yourselves and trying to solve questions and being unable to solve some of the questions, so that you come to me or to the assistant to ask for help, how to solve some questions. And the good example, as I always say, about exercising is the football game. Right? That's an excellent example. I know football. Right? I do know it. I know the rules. I know how a goal is made. What is goalkeeping? What is offside? Such things. I know the rules. But I'm not very good at playing it. Okay? I cannot play it. In the examination, you're supposed to play. And in order to play, you have to exercise. You have to play and play again and again and again. You have to go to the grass field and play the football, kick the balls, and play it. And then you will tell me that you played well or not. And I will say that, okay, you know football, only by watching you. Otherwise, by saying that I know football, I won't be convinced. I'm just giving you the rules by teaching. But that doesn't necessarily mean that you will be able to solve questions. By just watching or following the course, probably you will understand. But when you look at the questions, you will also understand that understanding the course in the classroom is nothing. Because you won't be able to solve any questions. So how are you going to do that? By solving and solving again and solving again. Okay, lots of exercising. Starting from the trivial, going to the most complicated. Okay, so textbook and questions and exercises. And what else do we have? Okay. We know why we are taking this course. The projects. Okay, let's briefly mention about that. I hesitate about mentioning these things because I didn't decide on the projects yet. There are so many aspects of signals and systems. I will give you those examples. When I give you examples of signals and examples of systems, you will see that several amazing things can be considered as a signal or a system. So there are many types of projects that you may do. In fact, anything you may do by yourself could be considered as a project for this course. But I will decide on some finitely many options. And you will make groups of 6 people or something, maybe 10. To rather come up with a large project. So it will be a group project for you. And while doing that project, you will need to use the concepts that we will learn. But in order to start to the project, you shouldn't wait for learning them. You shouldn't wait for me to teach them. You should start learning them and use it as quick as possible. Otherwise, it boils down to something like this. You wait until the end of the course to learn everything, and then you start the project, and then you have no time, about 1 day or something. Okay? That will be a disaster. As soon as I submit the project, you have to choose your routes, register them with me. I'll have your names for each group, and then you will start. You will have to start immediately and learn. When you learn something by yourself, it's much more, it remains in your memories when you learn it. When we teach it, it won't remain for so long in your memories. You won't remember them. Most of the things that I remember from my undergraduate years are my failures. Okay? I remember when I did something wrong, because now I know it's correct thing. But I'm having difficulty in remembering the questions that I managed to solve. I don't remember them anymore. That's an interesting thing. So, in order to learn permanently, it must be your necessity. You need to learn it, then you remember that. Okay. So that will be the projects, but we haven't decided yet. I'll decide the project topics with the assistant. I'll talk to him and we'll decide on some projects. Now, before giving a break, I will write down the first quiz over here. And it's not a quiz of knowledge or anything. It will be just some questionnaire. You may think of it like this. So I'm going to write it here, and you will tear off some pieces of papers if you have. If you don't have, you may ask your friend to have some paper. Write your names on them, and then I will write the question here. Copy the question, and then we will talk. Now, while you're preparing your papers, do you have any questions? Do you have any questions? No questions. It's all clear. Everything is crystal clear. Well, I will say that. I'm relatively surprised that you have no questions, because there are several gaps that I didn't mention about. For example, the first thing, do you have the necessary fundamentals to be eligible for taking this course? Are you eligible to take this course? Who are eligible to take this course? It's a question form of this. Are we eligible? Is my question. You should ask it the other way around. I'll try to learn it by your answers here. How many people are essentially eligible and how many people are not very eligible, but they just somehow registered to this course. And those who are registered to this course are the non-eligible ones are the ones who couldn't pass some of the certain courses, like all the mathematics. Have you finished linear algebra? Have you finished all the calculus courses? Did you take probability? Did you take EEM 102, Introduction to Electrical Engineering? Have you passed system dynamics? And did you pass differential equations? And if any of the questions is a no, then there's a huge question mark over there about your eligibility. Then you're doing something wrong. So what are they? Let's start by the first question. Did you take this course before? It may be even the case that you're taking it for the second time, third time, whatever. You have taken this course before, perhaps. So this is the first question. Did you take calculus 1 and 2, linear algebra, differential equations, introduction to electrical engineering and system dynamics. But I'm not going to withdraw you or anything if you say no to some of these things, because it's up to you to register. But your success will be at jeopardy then. And did you take this course before? Is related to this third item. Let's say that the third item is. I can ask you like, do you know? Or I will ask it like this. What is convolution and Fourier transform? The answer to these two questions may be and should be, I don't know. But you may know, or you may have some idea. And if you know, or if you have some idea, I would like to know. And if you say, I took this course before, and if you say, what is convolution? The answer is, I don't know, that's a very strange problem. Because for those who have taken this course before, should at least know convolution, and should at least know what a Fourier transform is. And I'm not asking for the formula. No, right? I don't expect any formula or anything. I'm just asking for verbal explanations, if you know. If you don't know, if you have some idea, just mention about those ideas. Nothing else. I'm not asking anything mathematical. Okay? And I will stop at this point, lecturing. And for those who have finished this thing, should submit your quiz questions to the assistant. And we will start at 3 o'clock. Yeah?